You are now listening to the Big Data Beard. This is our podcast where we explore the trends, technology, and talented people making big data a big deal.
Data is the fuel for great artificial intelligence. Sadly, many exciting AI and big data projects fail to deploy into production because data engineering and data ops are complex, resource-intensive efforts, often taking months or even years. To find out how the data engineering process might be improved, we reached out to the team at Infoworks to learn how their agile data engineering platform automates the creation and operation of big data and AI workflows from source to consumption. We learn how to get more use cases in production with fewer resources on this episode of the Big Data Beard podcast. Amar, why don't you tell the audience a little bit about yourself and your background?
Hi, everyone. My name is Amar Arsikere. I'm the founder of Infoworks. My background is in building large-scale data systems. I spent a lot of time at Google building a lot of the big data technologies, and also built an analytics stack at Google, which is essentially running a lot of the internal applications, internal analytics applications, fairly large scaled-up systems running petabytes of data, thousands of users, and so on. After Google, I joined Zynga, where I built the world's largest in-memory database that's running all of the Zynga's gaming system, and also running analytics with 10,000 plus analytics pipelines on a 12,000 node cluster. That's my background, and that's the background of a lot of the engineering who has built this product. We have taken the experience of running large scale data systems in production and productized this with Infoworks.
We'd also like to welcome Ramesh to the Big Data Beard podcast. Ramesh, why don't you give us a little background on yourself as well?
Yeah, hi, I'm Ramesh Menon. I'm responsible for product management at Infoworks. I have over 20 years of experience in enterprise software, primarily in just the areas of data management, data transformation, and essentially data curation. So I started my career building high-performance matching algorithms for pretty much any country, character set, or language. And then later on got into data quality, address standardization, and those kinds of technologies. I was at Informatica for a while. In a number of different roles, I was responsible for data quality, data governance, and then later on involved in starting a new business around master data management, where I ran the go-to-market strategy. After Informatica, I was at Yark Data, where we built, at the time, and maybe still is, the world's largest appliance that had a shared in-memory system for non-obvious, data relationships and the discovery of them. Also, one of the products I launched was one of the first Spark optimized appliances in the sort of Hadoop and big data space, and I've been at Infoworks for over 3.5 years.
Tell us more about Infoworks as a company, and specifically what problems you're seeking to help customers solve.
Yeah, absolutely. So, if you see what's going on with, the world of analytics, and also, leveling up a little bit and looking at what's happening with the digital transformation in the world, you will see two sets of companies. There is the born digital companies like the Google, Facebook, Amazon, LinkedIn, Uber, Netflix, who have the capability to build large-scale analytics, pipelines, and then there is the rest of the enterprise who are at various, degrees of maturity. So today, what's happening is in the state of the art in building analytics use cases is, people can throw up 10 to 20 use cases in production in a year. But in order to get to a digital transformation, you need to have at least 100 or thousands of analytics pipelines running in production. So that lack of agility in analytics is the problem that Infoworks is trying to solve. And we have already got to a point where, we have, very large scale deployments, large scale customers who have got to this agility in analytics, where they're able to stand up use cases very rapidly. And the only way to do that, the only way to achieve this kind of agility in analytics is via automation. So we automate the big chunk of what takes what is required in analytics implementation, which is data engineering, and we have automated it. We have an end-to-end data engineering automation platform that gives you the agility in implementing analytics.
In the world of big data and analytics use cases, and as you said, data engineering is a key component of it, because data is the fuel for any of these workloads, right? If we have good data, we have lots of data, then we can potentially do things with it. And one of the terms that has been very popular in the last, call it 6 to 10 years, as we think about, big data, has been this concept of a data lake, right? And the concept of having lots of data available for the purpose of analytics. How would you view the world of data lakes today, and how successful have organizations been at truly achieving this data lake concept?
I think the more fundamental issue to be solving is data sourcing strategy. So creating data lakes is one approach of essentially gathering all the data for analytics, but I think there is a much more fundamental issue about solving all your data sourcing needs. The data could be internal data sources, external data sources, and so on. So we have taken the approach of data crawlers. The data crawlers can build a data lake either in sort of one single storage instance, or it could be distributing that partly in the cloud and partly on premise and so on. But the whole concept of data crawling is really to give you the agility in sourcing data from hundreds and thousands of data sources that you may have. It's not sometimes always feasible to build a data lake in one single storage instance and say that's the only place that I'm going to go and get all my analytics needs met. So the data sourcing strategy is even more foundational than the data lake creation. But having said that, I mean, data lake creation and management is still a good option to build out in many cases, as long as it's built in a very agile fashion. It should not take months together or years together to build and maintain a data lake.
When the advent of big data technologies really started in most enterprises, the data lake was seen as a way to solve magically a whole bunch of different problems. So in the past, data warehouses and the sort of traditional analytics infrastructure were limited because they did not handle more than a tiny fraction of an enterprise's data. Suddenly, with the data lake, there was infinite, or at least economically very scalable storage. And so the idea that you could put a lot of data into the data lake was very attractive. However, it's one thing to move data into the data lake, as Amar was talking about. It's yet another to actually make sure that it's being moved efficiently, that it's being kept synchronized, and all of those other problems that go with actually moving and keeping data synchronized in a data lake in a production or real-world enterprise scenario. So that was one set of challenges. The other set of challenges was that simply dumping data into a data lake without actually worrying about how people are going to consume the data led to terms like data swamps arising, where people were saying data lakes are a failed strategy because the data is not usable downstream. So data lakes are still a great concept. What they are missing is the ability to efficiently get data in and to efficiently use the data once it's in the data lake. And that's where I think a lot of the conversations around data engineering automation and tooling to help make use of the data in a data lake construct really applies.
What are some of the challenges that you're seeing organizations face with regards to data sourcing strategies? And how does the Infoworks platform help solve these challenges?
Yeah, absolutely. So in terms of sourcing the data from multiple different data sources, the biggest challenge is the type system between the source system where the data is coming from and the target system is different. So managing all the types so that there is no loss of data precision is a big challenge. And again, it's not a job suitable for humans. In other words, you're constantly keeping track of every database, every source database that is out there, and how do you map and manage the types and data precision is one challenge. The second one is, once you've got the data mapped and have the data moving, you need to optimize that data pipeline, which means you need to bring the data in parallel, where possible, so that you can meet SLAs. So the parallel ingestion is a non-trivial problem. Sometimes if you are bringing the data that is sitting in a very large file, you may want to chunk the file into smaller segments and then bring it in parallel, and then assemble it on the other side. So that's a challenge which requires coding and sort of managing those pipelines and complexity. That should be also automated, which Infoworks automates. The third thing is, a big data system achieves parallelism and scale by partitioning the data sets. So what is the right partitioning logic, and how do you sort of take one large table and segment that into multiple files so that you can have parallel processing on it is another challenge that you're going to have to manage. And Infoworks automates that process by providing a hierarchical partitioning mechanism where your tables and files are very nicely distributed, so that your data processing on top of it can be done in a very fast manner. The last example of the complexity is the entire CDC and merge process. So once you have brought the initial data sets, how do you perform change data capture, and how do you bring the changes in and merge that into the target data set that may be sitting in your data lake? So that's another complexity which requires coding, because the CDC process itself has got number of complexities. Some data sources provide logs from which you can look at the delta, the changes, the deltas, and then take those deltas and process it. And some data sources like files, they don't provide any indication of what the changes are, and you need to compute that. So all these processes are automated in Infoworks. Just to give you an example, any directory source, for example, can be considered as a CDC source or a change data capture source for Infoworks. It looks at the directory and computes the changes that was performed to the previous run, and then brings just the delta files into the big data infrastructure, and then processes that. So there is many more things that requires the automation, like computing the time series data, current tables and history tables is automated in Infoworks. Managing the schema changes is also automated. So if you have to do all of this manually for one data source, it may actually take weeks or months, and then try to manage this over 100 different data sources, or even 1,000 different data sources. Some of our customers actually have 1,000 data sources. Then it becomes a task for a very large engineering organization, and you will not get the agility, you will not get the speed that you are looking for.
You mentioned that this concept of change data capture, and I want to dig on that a little bit, because I don't know that everybody may not know what that term fully means. So if you would just take a minute and explain to me what change data capture is, because I think it is a unique approach to data ingestion, and as you said, scaling that capability and increasing the velocity of data access. I think it's an interesting concept. Would you explain the CDC a little bit for us?
Yeah, absolutely. So what happens is, when you have your data sources, the transaction systems or your business systems, they're constantly changing. They're changing every minute, every hour, every day, and so on. And typically when you're building your analytics systems, that's a read-only system that is got a copy of that data set that's, reflected in the business systems, your transaction systems. So your analytics pipelines may require reports or dashboards or any of the things that you're building on top of it that needs to be refreshed, say, every 10 minutes or 1 hour or whatever. So you need to bring in the new data the data that has changed in that last 10 minutes or last 1 hour or whatever that frequency is. One approach to do this is to bring all of the data every time, every run, right? I mean, you bring everything that's there in the source and process the entire data set, which is called the batch style ingestion. But the problem with that approach is that if the volume of data is very large, like it could be petabytes in some cases, that strategy is not going to work. Just loading that entire data in a batch mode might take several days. So that's not going to scale. So the change data capture is a strategy where you're computing the difference from your last run, the last ingestion run, and then bringing just the delta, the changes that happened since the last ingestion process was run. So that's the change data capture. And there are many ways to, do that. The one approach is some databases have logs, which basically have an indication of all the changes that happened. So you can read the logs and recreate exactly what happened on your business system. A second approach is to query the database and maintain certain metadata like timestamp or whatever, and then use that to query just the changes that happened since the last run. And in case of files, we keep additional metadata, which give us an indication of new files that came in, or files that got modified, because we can look at the timestamps on those things, and we compute the differences. So this would be the approach to look at just bringing the new and changed data into the analytics system.
One of the things that we notice, and I think you and the team at Infoworks is keenly aware of based on where you're investing, is that this data cleansing and ingestion and sourcing strategy and the data engineering pipeline is very challenging. But there's been a lot of both open source and commercial products like, that are ETL type tools that seek to solve this problem. So I'm curious, how is Infoworks different than maybe some of those other popular ETL type tools that people may be more familiar with in traditional analytics contexts?
So I think there are a few differences, and I should caveat that I did work for a number of years at one of the leading ETL providers in the past. So essentially, what's really different about what we're doing at Infoworks versus, say, a bunch of point tools that take care of maybe a portion of what I would call an end-to-end data workflow. So some companies or some tools focus only on ingestion, others focus only on data prep, others focus on maybe building things like OLAP cubes on Hadoop for consumption. So one fundamental difference is that we take care of the entire process from the data ingestion through preparation, transformation, optimization to consumption of the data ready for analytics. So in other words, if there is an analytics use case, all of that upstream process of getting the data ready for that analytics use case is something that we do entirely in one single platform. So what that means is that enterprises don't have to spend time and valuable data engineering resources to actually go stitch together different components and have to worry about not only the extra time and effort to build an integrated data pipeline, but then to maintain it, because all of these things, as you said, change a lot. Sometimes it's open source tools, sometimes it's commercial tools, and these things change, and it's up to essentially the enterprise or the customer to take care of that change. So that's one big difference. The other big difference is that many of these tools, especially the sort of the ETL tools or the data integration tools that have been around for decades, is that they were built to solve a different problem. They were built to solve hand coding of scripts. And so the approach they took was really around visual programming, making it easier for people who are hand coding to then move to a visual programming environment. We've taken it from a completely different approach. We say that the unprecedented use of automation that we have applied into our platform makes it such that it's a zero code environment, and that practically anybody, whether it's a data analyst or a data engineer or a data scientist, can get up to speed with implementing a use case all the way from data ingestion to data consumption with, in a fraction of the time with the other tools. So if I were to, summarize that, it's really about the fact that we are different because it's end to end. and it's automated. There is a third thing that we are seeing a lot of now that cloud has shown up, is that the platform is also architected to be infrastructure independent. So we have customers who start off, for example, on an on-premise Hadoop distribution and then say, oh, I will now want to move to, say, the Microsoft Azure cloud. And then, a few months later, other folks want to use certain technology that might be in the Google cloud and now want to move again. With Infoworks, the way the platform is architected, as I said, we can move from one to the other with just a few clicks because we are independent of the underlying execution engine. So not only can we move from one to the other, we are also essentially insulated from any change that happens underneath.
The ability for Infoworks and your platform to be such an agnostic platform is quite an interesting concept, because we're seeing so many of the tools today being tightly coupled to a particular data processing or execution engine. But I'm curious, what are some of the popular execution and processing systems that you're seeing customers use when leveraged with Infoworks?
Yeah. In terms of the execution engines, let me take a step back and explain, what is going on in terms of the different execution engines that are out there, and also especially in the cloud, right? In the past, you had this single node concept that a data process would essentially run in a single node, and you are sort of limited to that. With Hadoop and Spark, basically what you're getting is a parallel compute infrastructure where you can run your job on, break it into smaller pieces and run it in a cluster. So essentially, it's basically a compute infrastructure. You can think of it as electricity. I mean, you can sort of feed in your process into that, and then you can deploy it to run on as many nodes as you want. You have to follow certain protocols, but that's really what you're getting from it. So we are utilizing this new concept, this modern execution platform, modern computation platform, to do all of the work, whether it's ingestion, ETL style data processing, and then also data modeling, orchestrating, and everything is natively sort of built as on top of this modern parallel execution frameworks. We support any flavors of Hadoop, so it could be on-premise or in the cloud. So there are essentially three major distributions: Cloudera, Hortonworks, and MapR. We support all three. And the second thing we support is Spark. So you can take the same set of jobs and make it run on a Spark cluster, or it could be EMR. So EMR is the AWS equivalent of Hadoop. It could be HDI on Azure. HDI is the Hortonworks on managed Hortonworks on Azure. It could be Dataproc on GCP. And also there is these new serverless execution frameworks which are coming out. Google has something called as Dataflow, and there are other serverless options that cloud vendors are working on. So we essentially Infoworks workload can essentially run on any of this execution engines. So we from a philosophically speaking, we look at this as really electricity. We plug into it in any format that it's provided, but it's an underlying utility or infrastructure that we can tap into.
Can you talk a little bit more about the idea of data consumption and how you've integrated this crucial part into the Infoworks platform to help accelerate the ability to move data models into business applications?
So once the data models are built in a data pipeline, consuming these data models into a business application or a dashboard or a report is a non-trivial problem, in the sense that how do you get the performance that meets the requirements of the business? In order to solve this, we at Infoworks have built a data consumption stack. So it's not a one solution fits all. I mean, because there are different kinds of use cases with different kinds of query performance requirements. So if you're building a dashboard and you need sub-second response times, then we have a cube engine where you can push your data model into a cube engine. And then for those known data queries that you have designed, you're going to get sub-second response time. And that's fantastic when you've got, executive in the company slicing and dicing and looking at, different aspects of the business and so on. Now, the next level sort of use cases are things which may require response time in a few seconds, 1 second to 10 seconds typically, right? And your machine learning or, data science use cases kind of fall into this. Reporting use cases fall into this category, if you will. With Infoworks, we provide a mechanism where you can push your data model into memory, or you can push your data model into an analytic engine. It could be on-premise or it could be in the cloud, which gives you that kind of a performance. If you are in the cloud, we can push incrementally the data models into something like a BigQuery or an Athena database in case of AWS, or it could be a on-premise PrestoDB, right? So that gives you the 1 second to 10 second performance. And what Infoworks is doing is incrementally exporting the data models into this analytic engines so that you can, consume it at the speeds that you want. And the last one is, the data models that are in the data lake. Again, the Infoworks automates performance optimization of the data model on a big data system by doing partitioning, indexing, Bloom filters, sort orders, and all that stuff, and gives you the best performance for that layer. But typically, the response times could be in 10 seconds and above. And that's suitable for doing ad hoc queries and some certain kinds of batch processing. Now, all these solutions are available in a single integrated platform. So you don't need to go and procure, another piece of hardware, software, just because your use case, query performance changed on you. So you're basically promoting those data models from one layer to the next layer and so on. And there is also this concept of a SQL router, where if the data set is not in a cube, for example, it routes the query to the next layer down so that you always get a result set, but the performance is really dependent upon which layer the data model is actually built in.
One of the things that we've talked about is that this idea of scaling a data engineering pipeline is a non-trivial thing. Help me understand, what are some of the challenges that people traditionally face with some of these tools when they think about their, this massive data sourcing strategy, and you've got this variety of, data processing frameworks? What are some of the challenges that you're helping customers solve around scaling, not only just building it, but actually scaling and hyperscaling a true agile data engineering pipeline?
There are two aspects to scaling. So one is just the number of the data pipelines that you need to manage and run, right? So it's just the analytics pipelines at scale. It's one thing when you're running 10 use cases, you perhaps don't need as much automation and so on, and you can have engineers sort of manage that. But when it increases by 10x, automation is essential. At 1,000, you are not able to run it just with the engineers sort of managing and so on. There are a number of challenges in terms of the analytics, running analytics at scale. The first thing we talked about, just keeping track of all the data sources and managing the type system, the schema changes and other things is a big deal. The second one is in terms of data transformation. So once you have data sources are made available in a data lake and you're building data transformation logic, how do you run all these, transformation pipelines on a shared cluster? You need to be able to orchestrate that. You need to be able to schedule it. You need to be able to, pause these pipelines in its execution. So sometimes you have a very urgent process that needs to run. And when you pause something, it needs to go into the disk in a graceful state, and you can recover back from that state, right? All this requires automation. All this requires, essentially, a process which takes care and of that sort of the capability to pause and resume and so on. It also, the pipelines themselves have to be fault tolerant to things like machines going down, network going down, and things like that. Again, having an automated orchestrator which puts the state of every pipeline into a known state onto disk and recovering from that state, retrying those pipelines, and built-in fault tolerance becomes much more important. Otherwise, you're going to have an army of people babysitting all these pipelines, and in fact, there'll be more people just babysitting pipelines than the number of people who built it in the first place. And I've seen that happen, firsthand. So automation is really critical. I mean, to run this analytics at scale. The second aspect of the scaling is what happens when your data size keeps increasing. You need to be able to meet your SLAs. So all your processing, from ingestion process, the merge process, the CDC and the merge process, your transformation process, your data model building process, they all need to be built in such a way that they can scale. If you double the cluster, it should reduce the build time by half, right? So having those algorithms, we have built all these algorithms to scale that way, where if you increase the cluster size, it will reduce your build times linearly. So those things are also very critical.
One of the things that we're seeing is that when automation comes into play in really any system, governance becomes a concern, and there's a need to explain the pipeline and the transformation. How does Infoworks approach this concept of providing governance capability in these large-scale data engineering pipelines?
So governance takes a number of different forms, both in terms of the type of data that's being processed, as well as what the organization needs to do from a compliance and audit perspective. So we offer multiple layers of data governance, so that enterprises can actually stack up those things to meet their requirements. But one of the key things that we do that's different from any other set of tools in the market is that we automatically maintain end-to-end lineage of data and metadata across the platform. And we are sort of uniquely positioned to do that because we do have an end-to-end platform. So it's something that we keep track of automatically. So what this means is that when an analytics user is looking at a particular data set, and maybe they're performing analytics, it might be running a report or some such similar activity, they can actually go into any particular data attribute or a column and say, where did this come from? How did it arrive in this state? And with Infoworks, we can map it all the way back to a source system. So we can map it back to a data model that somebody created. Maybe another data engineer created this particular attribute. Maybe it's a computation of total sales or currency conversions to a single common currency format. You can trace all of that back and say not only what happened, but who did what to it, all the way to, and it was derived off of these columns or these tables or these data sets that came from these particular source systems. So all the way back there. So what that does is it provides that essential layer of, metadata lineage, auditability that's essentially a sort of foundation or a building block for any data governance activity. So from there are other things that we can do. So a lot of data governance is also about, can I make sure that data that's showing up into the platform is protected and secured and is being used in the right and appropriate way? So all the way from when we get data ingested into the data lake, we can mask data. So for example, if there's PII data or there's HIPAA data or PCI data and all these different things, and maybe the data lake or the cloud data lake has not been certified to store that level of information, we can mask the data at source and make sure that that source social security number or credit card number doesn't even make it into the data lake or does not even travel across the wire. Once the data is in the data lake, we have integration to a variety of data security projects and tools so that the data is secured not only sort of at an Infoworks level, but at the base data level so that access is always governed through a single format. And then in addition to that, we also have role-based access control and domains. I mean, we call them domains. It's equivalent to project workspaces that are, both collaborative in nature as well as role-based access control frameworks, which allow people to work on the data that they are provisioned to use. So in other words, if I'm in marketing and I only have to see leads and sales, I don't actually get to see other data that I'm not supposed to see. Whereas another data engineer might be working on another project where they do have to see some, data that might be sensitive for me to see. So all of that is supported in the platform, and there are constructs in which to do that. So, I'll summarize it by saying that data governance has so many layers and so many levels, and a comprehensive approach is essential. And that's what we've taken at Infoworks, all the way from, data flowing into the system, how it's being used, how it's managed, and then the visibility into that, which is very critical.
If you were to say kind of the summary of what does it take to build a successful agile data engineering pipeline or platform, what would you say those key pillars or those key tenets of a truly agile automated data engineering pipeline looks like?
In terms of building an entire data engineering pipeline, I mean, you have the first part, which is the ingestion and the CDC and merge. So you're constantly bringing the changing data from the source system and keeping that synchronized. The second one is to cleanse that data and transform it and add your business logic, which is the entire data transformation component of it. And the third one is to model the data so you can, consume it. So it's, some people call it the semantic data models or business data models, the data models that the enterprises can consume. The fourth one is to accelerate these data models. The data models that are generated and stored in a data lake, it could be in S3 or it could be in HDFS. They're not performant. They're not, they may not give you the query performance that is required for the use case. So you need to accelerate that data model either by pushing into an in-memory data model or building a cube around it and so on. The next one is orchestration, which is connecting the dots. Connecting ingestion, connecting data transformation, connecting data modeling, and the data acceleration components. And also, there may be some external data processing that you may be invoking. So connecting the dots into a single use case is what we mean by orchestration. And the last piece is the governance component, which is who made what changes when. Because once you have built this data pipeline, it's got a life of its own. People need to make certain changes. People need to, work with a new schema and so on. So that's the entire governance and the lineage part of it. And then, making sure that when you are running this in production, you have the ability to monitor it, you can debug it, and also performance tune it, is all the things that goes into a data engineering pipeline. With Infoworks, all these capabilities that we just talked about is built in a single platform. So you can not only go and build this data pipeline once, but you can maintain it on an ongoing basis. You can go to production with it. You can validate your data sets. You can do your reconciliation processes, all automatically. So there is a significant amount of, maintenance work that gets automated once you have built the data pipeline.
So when you look at the market and you kind of look out there on what is Infoworks really focused on, kind of the next thing you're trying to work towards or the next thing for the business, where's Infoworks going next? What's the thing that you're looking at and you're saying, this is what we as Infoworks are going to be, delivering and working towards in the next 12 months to really continue to solve customer challenges uniquely?
So one of the things that we are seeing is our customers are migrating to the cloud. And that's throwing up a set of challenges. One thing is the cloud journey is not going to be this one big bang. Okay, here I am today, and then tomorrow I'm running in the cloud. There has to be sort of a gradual sort of migration. So as a result, what's happening is some data sources are on the or inside the premise, and some data processing is moving into the cloud. So we already have a hybrid sort of a hybrid environment support, and we are going to continue to invest in sort of building that out by providing different options, such as serverless options that you can deploy Infoworks on. There's another part of this whole thing, which is the entire enterprise to cloud integration. So enterprise to cloud, we call it the enterprise to cloud bridge, where you can run your CDC pipeline through this enterprise to cloud bridge. So some data sources may still reside on premise. So you can use this sort of a bridge to kind of, make that processing happen. So the cloud is a big, focus area for us in this next year.
So I think when you look at sort of the foundational elements of what the Infoworks platform provides, it really can be summarized as three major pillars, if you will. One is automation. And the second one is really about the infrastructure and independence, and then the third is about the end-to-end platform. So our focus areas overall will continue to be in those in those three areas. So automation, is and will continue to be a very heavy focus for us. We have a level of automation in the platform today that's not apparent in any of the technologies and tools that are out there. So we'll continue to invest a lot more use of the analytics and the data, not the data that the customer is actually working on, but the data about the kinds of things they're doing, that we can then be smarter about doing things like better recommendations and essentially easing the work of the data engineer. Ultimately think of the automation as a goal where anybody can show up and with a few clicks build and deploy a production use case, right, in a matter of minutes. That will be our ultimate goal with the automation. When it comes to the end-to-end, we are continuously adding functionality that will help customers sort of complete their use cases, either through the use of Infoworks or through integration with third-party technology that they may want to layer along with Infoworks. And then the last one, which Amar talked about, which is really about the infrastructure independence, is where the vision is really to be able to have users run their workloads anywhere without having to worry about what infrastructure they're running on, or whether it's in the cloud, whether it's on premise, where the data is coming from, where the consumption is going to be, because that's really where I think a lot of the enterprises are going to. In fact, one of our customers has got 3 different implementations, one on premise, one in Azure Cloud, and one in Google Cloud, with data engineers and data consumers at all 3 sort of venues. So those are the sort of the overall focus areas for us that will continue: automation, end-to-end, and the infrastructure independence.
Hearing how other organizations have solved some of the same challenges that others are facing is a really powerful tool. Do you have any examples of customers that have had in the past some unique challenges that without Infoworks, they had some struggles? And then how Infoworks came along and helped them solve that challenge? And then what was the overall outcome at the end?
Yeah, absolutely. So this one use case that is really exciting is at a high-tech company here in the Bay Area. And the challenge that they had built a data engineering platform over a matter of 2 years with their internal engineering resources. But their challenge was continue to invest and continue to put their brightest engineers on building a platform that's not core to their business, right? So they did an evaluation of some 8 to 9 different products out in the market, and they selected Infoworks over all the other tools that they saw. The thing that they got excited about is the level of automation that we had built in. And especially around the ingestion, synchronization, and building of the time series data lake and so on. So this was a data services or a platform group within this company, and they were providing data sources and sort of prepared data sets for analytics consumption for the rest of the companies. Think of it as the reference data for the entire company. Was the mandate or the charter for this group. So they took their engineering resources and actually put them to solve a business problem, which was like every time there was a request coming from the business saying that I need this data source or that data source to be synchronized every 15 minutes and, give this data set for the next 6 months because I want to run a data science experiment. They had to, have engineers go and do all that work. So instead, they took these, bright engineers and built a data shopping cart on top of Infoworks. So the business teams, the data analysts, the data scientists can literally go for shopping, like the Amazon, and look at the entire catalog of data sets that are made available, shop for their data sets, and also pay for it through their internal chargeback mechanism, right? So that you can pay for the infrastructure that is required to fund all of this build out of the data lake. So by building that data shopping cart, they have been able to onboard 1,500 data sources in a matter of 2 months in production, and keep it running, keep it maintained, and so on. So this is this is an exciting sort of a use case. So suddenly, they were able to unlock the potential for taking their engineering resources and utilizing them to solve problems that are closer to the business, instead of doing work on the sort of the plumbing layer or writing code for ingestion and so on. So that's a sort of a very exciting usage of the technology, usage of the automation, and then unlocking the potential within the enterprise. I think
if I were to say at a high level, Infoworks really delivers. I think, Ramesh, you said it well on these 3 key pillars of, this transformation, automation, and then end-to-end platform, right? That's truly unique. And it feels like it's supercharging the data engineering process, scaling the ability of organizations who have data engineering capabilities, but just accelerating, their capability of delivering back to the business unique value, and then allowing organizations to deploy in a truly, decoupled manner where the platform for data engineering can support a variety of data processing frameworks. Really interesting concept, and I think it's one that's unique in the market, as you've well said. But I'm curious. I want to go up a level with you on just get your opinions. You both work very closely, not only in the the big data ecosystem, but with customers that are solving unique challenges, or organizations that are struggling or kind of looking at technology. And I want to get your opinion. Like, what are those big kind of trends or challenges that we have to deal with in the market, in the world ahead of us, to really unlock the power of big data and AI? What are those big, just kind of macro trends that you're seeing in the market that you think that as enterprises we're going to have to attack in the next 12 to 18 months?
As enterprises are building their analytics systems, I think it's very clear that managing a very large cluster to run and execute all their data processing is a non-trivial job. So most companies, unless it's part of their core business to run a cluster, are going to look for solutions elsewhere. So that's one trend that we are seeing, and that's also accelerating the migration to the cloud, right? So that is one thing which we are focused on, to provide a environment where you can run your analytics in a hybrid on-premise and cloud infrastructure, or to run it in a multi-cloud sort of infrastructure. So today you may be running your data processing on Azure. Tomorrow you may want to run some of it on GCP and so on. So providing that infrastructure abstraction is one thing that is going to be very key. And that's one thing that at Infoworks we have actually seen customers do that with today with the Infoworks platform. The second thing we talked about is to really the agility in analytics. The number of use cases that the enterprises have to deal with is just accelerating, right? And again, you cannot achieve digital transformation without that analytics at scale. And the argument that we are making is that really that you cannot achieve that agility in analytics without automation. humans, I would say, are not even suitable to do this kind of a job. Machines are much better at it, and that's one of the key elements of of the problem that we are seeing that the customers are facing.
So my top three are somewhat similar to what Amar just talked about. I think one sort of macro, if you will, sort of raising above the technology is really what's happening at sort of the C-suite, if you will, at the enterprises. This whole discussion around digital transformation is really sort of raising the visibility and also the importance of analytics and data strategic value to the CXO level. I think for many years, certainly in my experience, data and analytics was viewed as an IT function. There were certain things that were done with the data and certain operational benefits were realized, but with not only some of the digital natives that are showing many of the traditional enterprises how to compete and compete better in their own industries, that every enterprise is now looking at digital transformation, and that's raised this visibility of analytics. What that means, of course, is that while it's great for data and analytics practitioners in enterprises because their work is seen as more important. It's also getting more recognition of how it drives how their own enterprise is succeeding in the market. It also means that the pressure on them has increased because now you have additional pipelines. The CEO gets some ideas. And this is being discussed at a board level. So the pressure and also the volume and the productivity of these data and analytics and more specifically data engineering teams is going to grow. And that's actually good. Enterprises are beginning to see the value of data and analytics at an unprecedented level. The other part is really about the next step of that, as this visibility and the attention and also the resources that go to these data and analytics projects means that a lot of these use cases are actually going to get operationalized, or they will have to be. So when a CEO talks about wanting to do a next best offer to a shopper who's coming into one of their retail locations, that has to get operationalized. It has to happen rapidly for the business to realize value out of those kinds of activities. So there's a lot of focus on not only just doing data and analytics in an experimental fashion, but actually making it work, running 24/7, lights out, and that's a whole nother sort of level of automation, of automating the operationalization and the management of these data pipelines as they continue to run. And lastly, it's really along the lines of what Amar had also mentioned, which is hybrid data analytics. Nobody is really invested in should this be big data? Should this run in the cloud? Should this, deal with this type of data or that type of execution engine? At the end of the day, it's about how is analytics going to move the needle on my business? And so run data and analytics, run workloads wherever it's optimal, access any data no matter where it resides, but govern all of that so that it's secure and it's compliant with various regulations. And that's really at the end of the day what most of these enterprises are talking about. So this hybrid notion is going to grow, and we're already seeing evidence of that. So those are my top three.
So for our listeners out there that really want to learn more about the Infoworks platform and to engage you and your teams, maybe set up a demo or meet you at some conferences, where can they go and do this? Where's the best way to go and learn more? And then which conferences will Infoworks be at this year?
So if any of your listeners want to learn more about Infoworks, I recommend visiting our website. So that's www.infoworks.io. And there's a variety of resources on the website itself, and there's also mechanisms for contacting us to learn more. There's a 12-minute demo, which actually walks through the entire platform in an abbreviated 12 minutes, which should also give people a nice sort of overview of both the automation as well as the breadth of the platform. In addition, we are on all the typical social media channels like Twitter, on LinkedIn, and so on. And we are also present at a number of data and analytics and big data conferences. I believe the next one that's coming up is really the Strata Data Conference in San Francisco. I believe it's at the end of March. So look for us at all these places as well as at the conferences, and we'll obviously have more information about what events we are going to be at on our website also.
We've learned a lot from our guests about big data, but now it's time to get a bit personal in a segment we like to call Rapid Fire. Pew pew.
Amar, what is the last great book you've read that you'd recommend to our listeners?
I'm reading one right now, which is called Catching the Big Fish by David Lynch. So I'm a big fan of philosophy and consciousness, creativity, and all those things. So that's a book that I'm currently reading.
Very cool. Ramesh, what about you?
So this is a little off the wall. It's a book called The Black Strat, which is really specifically about a 50-year-old guitar that was used by the lead guitarist for Pink Floyd. It had an interesting journey. It was bought in New York and toured the world and ended up at a Hard Rock Cafe in Dallas. And it appears that it's going on auction pretty soon at Christie's and is expected to earn a few $100,000. So I got the book mainly to get a little bit of a glimpse of rock and roll history, but also how a 50-year-old guitar can end up with being at an auction for a few $100,000.
That's wild. So speaking of music, Ramesh, what song would be playing for you if you were to walk on stage at a big conference or something like that? What would be your walk-on song?
So it would have to be, some variety of vintage classic rock and roll, but I'm thinking probably anything from probably Guns N' Roses' Appetite for Destruction would work fine for me.
There you go. Amar, what about you? What's your walk-on song?
I listen to a lot of the Bollywood songs, the old Hindi music and so on. So that's sort of my taste in music.
I love the beat. I was in India. I was in India last month for about a week, and we actually got to see some wedding parades, and the drums and everything. The beats were just. That stuff gets in your soul. It is so good. I agree. So I'm curious, Amar, what piece of technology is currently making your life worse?
I'd say one of the things that we as a sort of the technology family, if you will, have not solved is managing the complexity around sort of the large clusters, right? And I would say that's been one of the challenges. Our customers are expecting this technology to be as mature as like an RDBMS that they're currently running, and but now they are solving fairly technical problems that they have been shielded before, right? And so I think that's one thing which needs to be quickly solved. I think cloud is definitely helping. Having all these managed services is definitely helping. But I would say we as a technology ecosystem could have done a much better job there.
Clusters are a real cluster. I get it. Yeah. Ramesh, what about you? What piece of technology is making your life worse these days?
So Amar covered some of the work-related stuff, but I think another piece of technology I think that many of us in our personal lives is really around this whole growth in home automation. I think there's a lot of interesting technology. I see a lot of parallels with automation that we do in Infoworks that are possible in the home, but the big challenge at home is that there aren't any frameworks and any standards and any common APIs where things can actually work together. So that's frustrating me at the moment, and hopefully it'll get sorted out soon.
Ramesh, what is your biggest personal money pit right now?
So I like working on old cars. So it's always buying parts for something that's broken or trying to source a part for a car that's been built 20, 30 years ago, where maybe getting those things from someplace in England or someplace in France is somewhat difficult. So my wife always looks at me and says, we need to tone that down.
You got to tell me if you're talking cars, you pulled the thread there. So what are you working on? Give us some details.
So right now I'm actually working on a vintage Mercedes sedan, and the other project that continues is actually an air-cooled Porsche 911.
Oh, very cool. So, Amar, what's your biggest personal money pit these days?
All right. So I recently bought a new house, and that's is requiring a lot of work on it in the sense that furnishing and so on. And I'm also doing one garage conversion project, which is taking my garage and converting into an office space. So, which
very cool. It's not easy. Those conversion projects never go as planned.
I just got approval from the city, but now it's the hard task of actually doing it. So.
Yeah, absolutely. So, Amar, what TV show or series are you currently binging on?
Actually, I'm not watching as much TV as I used to before. The one thing that I'm following, I don't even know what is this name, and it's on Prime. I guess I don't get to watch as much TV.
That's an appropriate answer. I get that. Ramesh, are you getting to watch TV? If you are, what are you watching?
Yeah, I do. I like fishing a lot, so I've been watching the last season of this show called River Monsters, which is really about this guy. I don't know if you're familiar with it. Is a guy who goes around the world trying to catch big, fierce freshwater fish. So it's relatively entertaining for me. So that's what I'm binging on.
Some of those things he pulls out of the water scare the fire out of me. I thought rivers were safe to swim in. Not apparently. Right. So, Ramesh, are you going anywhere super interesting soon?
Well, actually, I'm going to India. It's a work trip in a couple of weeks. So we have an office in Bangalore, and it's always great to visit the team and get to eat some really good food again. So.
Absolutely. Amar, how about you? Anywhere interesting soon?
Nothing interesting. I mean, again, a work trip that's coming up to East Coast, but that's the plan for the next couple of weeks.
Be sure to visit Infoworks.io to learn more about their agile data engineering platform that's eliminating complexity through automation. You can find more useful links in our show notes.
The music from this episode is by Andrew Bell. Check him out on iTunes or Spotify.
Thanks for listening to the Big Data Beard podcast.